All right, today we wanted to do an introduction to vectors. So vectors are, a vector by definition is a quantity that has both magnitude and direction. Magnitude and direction. Any Despicable Me fans out there will recognize the evil vector. We had both. Our notation for vectors is like this. We could say a vector goes from A to B. That says it's a vector. A magnitude, the distance from A to B, and it has a direction. We can also just have a single letter there with a little arrow on top. Those denote that something is a vector and not simply an integer or quantity. All right, magnitude is the distance between the initial and the distance between the initial and term point. And we have notation for that. If we want to talk about magnitude of a vector, let's say vector u, put the u in between absolute value signs, what looks like absolute value signs, and that says this is the magnitude of the vector. It's not talking about direction here, it's just magnitude. So let's draw a little sample. If I have a vector that it would have an initial point A and it would have terminal point B, maybe it's got an arrow there, that is a vector. I know the arrow is at B because that's the terminal. The arrow is not at A. If the arrow was here, then this would be initial point B, terminal point A, but it's the, so let's say this is the initial, A is the initial, and B is the terminal. Okay, so let's talk about magnitude and direction. If I have a vector that has the same magnitude and the same direction, that's what it would look like. If I have the same magnitude but different direction, then I might even take a ruler and say, okay, that magnitude is an inch, and then I'm going to put it in a totally different, another vector can have the same magnitude but a totally different direction. If I have a different magnitude and the same direction, that would look like this. I would have a vector, let's say a long-ish vector, and then a vector of the same direction but a different magnitude. If I have different direction, then I might look like this. I have one, and then I have a vector there. They have different magnitude, they have different direction. So there's kind of your choices you have. All right, let's talk about the standard position. The standard position of a vector, similar to, we just came from the unit circle. The position on the unit circle was at 0 degrees, right? We had a unit circle, and this was started measuring angles at 0. With vectors, we're on the coordinate plane, and when you're in standard position, the initial point, A, will be at 0, 0. Will be at the origin. So let's, origin 0, 0. The initial point will be at the origin 0, 0. So let's look what we're talking about. I have a vector with an initial point at 2, 7 and a terminal point at 5, 9. So this, as it is. So 2, 7, x is 2, y is 7. There's the initial point A. And then next point, the terminal point 5, and initial point 5, terminal point 9. There we go. And so there's my 2 points, is the vector A. It is not in standard position because their initial point is not at 0, 0. So if I were to draw this vector, how I would, lift it up and put it right here. So let's look a couple ways to do that. I could see what's the distance from here. That's the along the x-axis. Let's look at that. We have a vector. Let's call it a vector. Now the distance along that it goes this way. So along the x-axis. So what we're going to do, we're going to say this is a vector, this is standard no vector, and I want the distance between this x value and this x value. So I take it. 5 minus 2. 5 minus 2. You should recognize that from the distance formula. x2 minus x1. We're the same thing with y. What is the distance along the y-axis for this vector. And this would be 9 minus 7. 9 minus. So when you have 2 points, form of a vector is going to look like this. U equals 5 minus 2 is 3, 2. Now let's draw that. I draw this. This is a vector, and I draw an x value. I start at the origin, and I have x value of 3 and a y value. That is the exact same vector as we have above. This one v and this one u. U is the vector in standard position. See that I found between the x's and the y's, and that told me what was the vector in standard position. What we still don't, the actual distance, we know the distance along the x and the y, but we don't know the distance from A to B, right? The straightest distance between 2 points. So that is our magnitude. So let's look at that. Magnitude, we have our vector. Let's keep our vector that we were just working with, u, that's a vector, equal 3, 2. So we know that that magnitude was, let's say x is 3, y is 2 in our example. So we know x-axis was 3, the distance on the y-axis was 2. Let's go, we know that magnitude has to do with all about distance. So what's the formula that we learned in geometry, maybe? Distance equals the square root of x2 minus x1 squared plus the distance of y2 is y1 squared. So hopefully, isn't this what we did to find the standard form of our vector? We did 5 minus 2 squared. We did 5 minus 2 to get 3, and we did 9 minus 7 to get 2. Already done this subtraction. So to get the distance, the magnitude of a vector, we take the square root a squared plus b squared. And that is the formula, magnitude of any vector. So let's calculate the magnitude of u. The magnitude of our u vector is the square root of squared 3 squared plus 2 squared. U equals the square root plus 4 equals the 13. So the distance between our A and our B is the square root of 13. So let's do another one together. We're going to find the magnitude of vector AB, the initial. And so the first thing we want to do is we want to find the A and B. So we have to subtract. This is equal to x2 negative 5 minus x1 positive 4, and then the y3 minus a negative 6. Please write out all of the signs, or you'll get, it's easy to get. So negative 5 minus 4 is negative 9. 3 negative 6 is positive. Vector AB, this is for our vector. This is a standard form. And if I were to draw it on a coordinate plane, I would have an initial point at 0, and I would have the terminal point at negative 9, positive, and that would be, it's orange, that would be over here. Okay, there's my initial, there's my terminal picture of my vector. So we're not talking about direction just yet, but we still haven't found as in standard form, we need the distance. The magnitude of AB is equal to the square root of negative 9 squared, A squared, plus 9 squared plus B squared equals the square root 1 plus 81 equals the square root of 162. Really, we could do that on our calculator and see what that is, but we're not, just leave it in that form for right now. So, there's the magnitude. All right, that's magnitude. All right, you guys try these. Find the magnitude of vector AB if A is this and B is, and then again. And we'll check your answers in class tomorrow. All right, I'll see you tomorrow.